The office was like the inside of a 15-year-old's trainer, and work was slow. I hadn't had a real case for weeks. I was just doing some essential research on the fashion pages when a stranger came in. He was just what you expected from a stranger. Tall, dark, and strange, and hardly the communicative type. Just handed over the tape and left the way he came. Well, it looked like work, or a very strange way of selling insurance. Nothing on the tape but a date. What had I got to lose?
We represent a large company in the textile industry. A new fabric has appeared on the market, and we are seriously worried. We want you to find out what it is. If you take the case, all we can provide you with are this tape and some samples. I'm afraid it isn't much to go on. Good luck.
So what does that tell me? Light? Soft? Could be a natural fiber, but tough enough for ski wear. Sounds synthetic. I figured I'd better get started. I found the samples, and they were as interesting as the first page of a telephone directory. But you gotta start somewhere. I started with what I knew. Always a good idea. Interesting. You don't need to be a scientist to spot some of the differences here. Wool. Twisted, rough, opaque. Cotton. Similar, but more segmented. Both of those are natural fibers. Nylon. Smooth and clean. A bit transparent. It almost glows. But now for the $64,000 question. Nylon on the left, Fibre X on the right. So is it natural or synthetic? I was stuck. But what do you do with a scientific problem? Take it to a scientist. Doc Savage's lab was like you'd expect a lab to be, only more so. The man in charge wasn't. Dirty fingernails and an even dirtier coat. But it was information I needed, and that's what I got. Nylon, he said. Watch this. But what's happening? I said. He explained. The two solutions don't mix, but where they're in contact, a chemical reaction takes place. Molecules from each solution react together to form a chain, alternately one, then the other. The chain gets longer as it's pulled up onto the glass rod. This thread is nylon. Nylon is a plastic. It's a polymer, but a polymer with a difference. These are the two precursor compounds, two monomers. To understand the reaction, you can ignore the central portions. Watch the chemical groups on the ends. The monomers join up by splitting off a water molecule. But what do you notice about this new arrangement? He said. It has the same reactive groups on the ends as the monomers. Good thinking, Detective. That means the chain will continue to grow. But each monomer added produces another water molecule. That's why this is called condensation polymerization. Water condenses out as a nylon fiber is made. Interesting, but it didn't help. Fibre X didn't even look like nylon. He agreed, but said it was synthetic. I asked him to prove it. Simple, he said. All you need is a flame. First, cotton, natural fiber. It burns. Now nylon, synthetic polymer. What happens? It melts. Now Fibre X. So it was synthetic, but with a twist. So what did that tell me? It didn't tell me much, so I left it to the experts. This is nylon thread, attached to a machine that will put it under tension. So how does that compare with Fibre X? Fibre X on the left, nylon on the right. First, both of them are strong, but X stretches a bit more than nylon as the twists unwind. Then it begins to fray. Does that remind you of anything? Yes, wool. Perhaps that could explain its softness. I was getting there, but now it was time to get invited to a place where they make the stuff. So I got myself invited on a visit. Said I was interested in buying new fabrics. He showed me round. Weaving, dyeing, and finishing. Nothing unusual to report there. Could have been any fiber. Probably was.
The latest range of tactile yarns to be introduced are those that we've developed for hosiery. When, again, from the market research and trade research we've done...
Then I found something. Something my clients didn't know. The company was starting to make tights from Fibre X.
Then fashion had become number one rather than performance. But to our surprise, then the consumer was saying now that comfort and touch of hosiery was very, very important for this garment.
Ever wondered how they make stockings and tights? They're knitted. But have you ever tried knitting a tube? Not so easy. Unless you have hundreds of needles, like these. The yarn is fed in as a continual spiral. To make the toes, just stitch up the end of the tube. But never mind the technology. Look at the fiber. Could be Fibre X. Except for one thing. Too fine. But apparently not. These dark fibers are human hair. The white ones are Fibre X. It can be made this fine. They call this stuff microfiber, and they call Fibre X tactile. But they did mention a problem. I was upstairs talking to the designer. She showed me samples of tights for the summer after next. At least I'll know what colors to wear. And that was the problem. People want intense colors. But to do that with these microfibers was taking much more dye than with normal, thicker fibers. Why? Why would microfibers need more dye? I was still puzzling about that late into the night. It seemed like I'd found out half the story. I decided to call it a day and took out a video. But no relaxation there. It was the ski suits that bugged me. No pair of tights would stand up to that kind of punishment. But maybe if the fiber was thicker and woven more tightly. Nylon ski suits used to be popular. They're very hard wearing, particularly on the eyes. Skiing is a very fashion-conscious business. Maybe it's more important to look good. The tape showed some suits made from Fibre X. They look good, soft to the touch, but are they as tough as nylon? Certainly looks impressive, but hardly a scientific test. I needed another expert, not a stuntman. Maybe this is a new fiber's weak spot. I needed some facts and figures. So how do you compare the wear on a fabric scientifically? Well, take a sample, bolt it onto a pad and rub it against an abrasive surface, 20,000 times. Cotton really can't take it. But old, shiny nylon is hardly affected. What about Fibre X? I couldn't believe it. No change. They had something as tough as nylon, but without the drawbacks. People like wearing natural fibers, like cotton, because of how they feel. Nylon might be harder wearing, but the ski suits weren't as attractive, so sales dropped. Now that's what I call fashion. Bright colors, skin tight and stretchy. And that puzzled me. My sample of Fibre X didn't stretch that much. But some fibers can. I mean, the concept's easy. Under tension, some fibers will stretch to 5 times their own length, like this lycra. But how? If you want stretch, you've got to design a particular chemical structure. It's still a polymer, but you take the polymer chains and join them together. At certain points along the chains, there are rigid links. In between the links, the chains are loosely arranged until it's stretched. Relax it and it pulls back to the original length. The fibers people call this type of fiber an elastomer. That's why cycling shorts stretch. But there's toughness and toughness. I decided to put them to the ultimate test, the washing machine. You know when you wash synthetic fabrics, some keep their creases, but others need ironing. What has that got to do with the fibers used? Take a nylon shirt. You have to iron it. Why? Well, I've noticed scientists like demonstrations. Must be a disease they catch. So I thought I'd have a try. Cool a rubber ball in liquid nitrogen. Hit it with a hammer. It's no longer rubbery, it's rigid. But warm it up and it's back to a ball, soft and flexible. That's what happens to synthetic fibers. Remember, they're like plastics. Coal fibers are fairly rigid. Heat them up with the iron and they soften as you press in the crease. But as the fabric cools, the crease stays there because the fibers become rigid. But every time your clothes go back into the wash, they get heated again. So why do some fabrics not need ironing when they come out of the wash? It looked as if I'd cracked it. I could relax. But my job's one you can never put down. When I play squash, I normally watch the ball. This time I found myself watching sweaty t-shirts. Why wasn't the green shirt getting wet? Surely not Fibre X again. It's not every day you get the kind of offer I made him, but everyone has their price. I took the shirt back to the office. Where did the sweat go? Not a nice assignment, but someone's got to do it. I compared two samples of cloth. Like to guess which was which? Cotton on the right, Fibre X on the left. So that's where the water went. What's going on? The shirt has two layers. Tactile, Fibre X, next to the skin. Cotton on top. Moisture from the skin moves through the tactile fibers and into the cotton layer. Then it evaporates. But why is the water drawn away from the skin? Could it have something to do with the unusual shapes of the fibers in the tactile layer? I decided that was something for my clients to find out. My job was done. I sat down to write my report. I told them straight. Anyone who can design a textile that combines the best properties of natural and synthetic fibers is on to a winner. I advised them to get to work.